This problem and all other CALC 152 problems can be found here at Sarai Studies. Link is in the description box below. We want to know if the following sequence converges or diverges. What does it mean for it to converge? Well, a sequence is just a list of numbers that goes on forever. And the big idea is as these numbers go on forever, they start just being the same. It's still going to go on forever, but it's going to be like 1, 1, 1, 1, 1, 1. So we say that the sequence converges to 1. And if it diverges as the numbers go to infinity, as the list keeps going, the list still goes on forever. It's just that the numbers just end up being different numbers. So we just have to take the limit as the numbers of the sequence go to infinity. And if you go ahead and plug in infinity, you're going to get infinity over infinity, which is indeterminate. And then I think, well, maybe let's try squeeze theorem. I asked myself, is there something in this sequence A of n that I can write as an inequality? Well, I look at this and I'm like, 1 to the anything is always just going to be 1. But specifically, if n ends up being an even number like 2, it's always going to be positive. So the most it could be is 1. But if n ends up being an odd number like 3, it's always going to end up being negative. So the least that this can be is -1. So now I have this fact, and the goal is get whatever's in here to be your A of n, to look like this. Because what you want to do is you want to have your A of n, and you want to find two sequences. I know in the intro video I did functions, but it applies to sequences as well. Two sequences, let's say B of n, C of n, one that's smaller, one that's bigger, so that this is in between them. And then you can say that if the limits of these are the same, if both of these sequences are converging to the same value, because this one's in between, it's going to be forced to also converge to that same value. But we want that to be A of n, we want that to be our sequence, so we have to get this to look like this. And so you would just add what's missing. First of all, we're dividing by n, and if you do something to one side, you have to do it to both. Then what else are we missing? Well, I personally go piece by piece, so I start by adding this. So we have a 4 multiplied to that 1, and then over here we have a 4 multiplied to that -1, and then here we just have a 4. And then you can simplify. This just becomes 4, this becomes -4, because note that it's only being multiplied to that 4. But then again, you still need to get this to look exactly like this, and so you add whatever's missing again. This time we're literally adding 3n. So we have 3n plus whatever was here. Here we're adding 3n, but that's just minus. And here we also added 3n, so now I have exactly what I have here. So now I have A of n, and two other sequences that I found that is smaller and bigger than A of n. And so the squeeze theorem says that if this is true, which it is, and we can find that the limit of both of these are the same, they're going to the same direction, then guess what that means for A of n, that's squeezed between those two sequences, is going to be forced to go in the same direction as well. So first I'm going to find the limit of this one. If I do infinity over infinity, I get indeterminate form. And you know that when you're dealing with limits where values approach infinity, and you have a fraction that's relatively simple and not something like this, you can divide every term in that fraction by the term with the largest power in the denominator. And since this is the only term in the denominator, you can divide every term by that. And so this would be 1, this would just be 3. So we still have the limit as it approaches infinity of 3 minus 4 over n over 1. And if you plug in infinity for n, you know that one whole divided into infinitely small pieces, that whole just gets infinitely smaller, so small, it goes to 0. So we really have 3 minus 0, which is just 3. So this sequence B of n is converging to 3. That means in the infinite list of numbers, it's just going to be 3, 3, 3, 3, 3, 3 at the end. Now we find the limit of this one and hope that it converges to 3. And again, you would divide each term in the fraction by n because that is the term with your largest power in the denominator. So you have 3 plus 4 over n over 1. And it's the same thing. You have 4 wholes. I just like to think of it as one whole. You divide it into infinitely small pieces. It becomes infinitely smaller. So small it goes to 0. This is 3 plus 0, which is just 3. So this sequence C of n is converging to 3. Since we have B of n and C of n are being limited to the same value, and A of n, our sequence, is in between both of them, guess what A of n is being limited to? The same value. Since it's squeezed between both of them, it's being forced to be limited to the same thing as well. So by the squeeze theorem, we can say that our sequence A of n converges to 3. And so then my conclusion is, since, and I just copied this, we found a sequence B of n that's smaller than our A of n and a sequence C of n that's bigger than our A of n, and the limit of B of n is 3, and the limit of A of n is 3, then by the squeeze theorem, the limit of our sequence A of n is going to also be 3. And so our given sequence A of n is going to converge to 3, meaning as the numbers in the sequence go to infinity, you'll just see 3, 3, 3, 3. It's still going to keep going forever, but it's just going to be 3, 3, 3, 3 because the sequence converges to 3. And that's it for this video. I'll see you in the next.